Welcome back everyone to the Hello World Guide. This is another episode of the OpenGL 3D render series, and if you remember, in the last video we implemented the shader side code for handling multiple lights in our scene, and in this video we are going to implement the CPU side code to actually allow ourselves to take in those different kind of lights and use them as well. So that is what we are going to do in this video. So in order to start, what I'll do is I'll go under scene.h. here you can see I've got a structure called material here. I'll go ahead and copy that, and I'm going to just paste it again, and this is going to basically be called light, and it's this structure is going to be pretty similar, in fact identical to the structure that we have got in our GLSL shader. So it will have a position like that, and also a color. So we want to make sure we have got these two. Anyways, we want to make sure we do that. And now when we are drawing, we are asking the scene to draw. What we will do is we will go ahead and before going over each mesh, what we will do is we will go ahead and use the shader only once. So we will say shader.use here, and we will set the value, but we won't set material.diffuse or anything here. Instead we will set it according to light values. Currently of course we have not loaded any lights. We want to make sure we actually do that, so we will use the shader only once in the start, and after that we'll go over each light and set its values here as well before we start drawing the meshes. And in order to do that, we need to have a vector of lights here as well, as it is quite obvious. So we will paste this here, and it will be called lights, and we need to load this vector from the actual FBX or whatever other kind of file format that we have got, and we can do that using Assimp, and that's going to be pretty simple. So before we do that though, what we are going to do is we are going to leave this and try to first of all make sure that we go over each of those and also do that. So we will run a range based for loop here. So we need to go ahead and run a range based for loop, which will basically go over each light in our lights here, and light in our lights. And for each light, what we will need to do is we'll need to basically do something very similar to what we are doing here, and what that means is that we will go ahead and paste this here, and we'll set this to we'll set lights, and then we'll need to actually do something else, which is that we'll need to actually keep a track of the index of the light as well, which is we'll need to take a size underscore I, which we will set to 0, and at each pass we will just increment that. So we will say I++, and what we need to do is we need to go over our lights, and I'm going to do this, then I'm going to end this here, and we are going to put a plus here to join the two strings together by concatenation. We will say std string string, and this is a function that will convert our integer to a string. So we will pass in I here, and then we will put this here as well. And you can see it's basically going to do this, and we will need to make sure we do this like this, and actually put the closing bracket as well, and we will need to make sure we set our position. And what we need to set is going to be pretty similar. It's going to be light dot position, very simple. And for the other value, we will just copy this, and I'll paste this here, and we will need to now set the light's color. So we'll say light dot color, and for the actual string here we will also choose light dot color. And apart from that, this is going to pretty much set our lights for us. Of course, what we are going to do is that in the end we are going to say shader.set value. Like you can see in the 3D render, we were setting its value num lights to 1. We are going to copy that and go here and set the number of lights, but we won't set that to 1. Instead we will set that to our I variable what we have got. And then what we will do is we will remove this from here. We'll leave the ambient color and strength, because that's just need to be set once, and we are going to remove the position at each frame as well. And right now we should have you can see that it's not exactly being able to get this correctly, so we need to make sure that we convert this to an integer, cast to an integer before we set our I here. And yeah, it's going to now get everything to be working correctly. And what we should be able to do is we should be able to go ahead and run our program like that, and what you should see is that we get a dark scene with only ambient lighting, because there are currently no lights in our scene. So what we will need to do is we'll need to make I'll just run this and see if everything still works correctly though. So you can see if we get this, and yeah, it's a very dark scene with only ambient lighting. So now the next thing that we want to do is we want to make sure that we read those lights from the Assimp file that we have got here, and we also need to make sure that we put them correctly in our light structure that we have got, so that we can use that later in our shaders. So what we'll do in order to read the lights from the actual file is that in the main loop, after we're done with the materials and the meshes, we are going to go ahead and run a loop over scene number of lights, and lights are just stored in the scene, and we'll for each of the iterations we'll get the light pointer using the mLights array. And then what we'll do is that with that light pointer we'll check if its type is equal to AI light source type underscore point, which means and as I said before, we only support point light, so we need to make sure that the type is point. And what we'll do is we'll set light, my light, we'll create like this is for our own light, the actual light structure that we have got here. This is not an AI light, the actual Assimp light, it's our own light. And what we'll do is we'll set its position, and we'll get that using a vector 3, and we'll set it to equal to the AI light's position. And we'll do similar thing with the color, and here we'll use color diffuse. The variable we'll use is called color diffuse, and we'll use that to get our lights colored as well. And in the end what we'll do is we'll just go ahead and say color dot pushback, and we'll push back our my light RGB, and that works. We should be able to yeah, that pretty much is going to be, should be able to now get our lights in our scene correctly, and everything else works. So now let's go ahead and test that out. Actually go ahead and test this. What you will find out is that your scene looks horribly wrong and a lot of parameters are incorrect. Well, firstly, this is for a couple of reasons. First of all, we need to do something with something called attenuation to kind of make our lights be correct. And the second thing that we need to do is that the light position is actually incorrect here. The light is being positioned at an incorrect value. The reason for that is because the light is positioned according to the scene graph, and this position is only like an offset light source in space relative, which is relative to the transformation of the node. For this we need to actually get the transformation of the node corresponding to the light, and we need to calculate the light's position from that. So that is a bit that is something that we'll be doing in the next video, so stay tuned for that. Make sure to like and subscribe, and I'll see you in the next one, and share this video with other people as well, and bye.